Hey guys, and welcome back to the channel. In today's video, we're going to be going over this quickie project to get a feel for HTMX GET requests. In today's video, we're going to be building out this Rick Morty Dex, which is kind of a play on words for Pokedex and all things Rick and Morty. We're going to be able to see in real time that our queries are being updated using the HTMX active search features, and I'm going to be going over how we include some of the data in there when it's not coming from the element that's issuing the request. So let's get right into it. So the data from today comes from the RickAndMortyAPI.com, and they just have this plethora of information on characters. I believe it's 826 according to this, where we can fetch and get information. I only realized after that I put this together that it was kind of similar to what I had in mind. It'll serve as a really good case study for testing out some of the features with HTMX. As far as what we'll be doing and to reduce the load on their servers from everybody pinging it at the same time, I made this little script, which I'll include in the video description below, which you can either copy off the screen or grab down there. This also makes it a lot easier to test locally if you're on the go and don't have access to a hotspot. So this is more or less what the data set that we're going to be working with is going to look like. Each character is going to have a name, status, species, and all that kind of stuff. I'm going to pull from that. And for the backend, we can go ahead and create a backend.py file. Okay, and before I start adding anything to the backend.py file, we should create a little container, a little icebox for our stuff. And now that that's made, we can go ahead and activate it. So source bin activate. First thing I normally do is upgrade pip. So pip install -u pip. Next, we'll install a few dependencies. And now that that's out of the way, we can go ahead and start adding stuff to our file. Okay, so first we'll add a few things from FastAPI, and then we'll add a few things that'll make life easier later. We'll import JSON and Uvicorn, which is going to host our app, and it looks like we have to install that. So pip install Uvicorn, and we'll go ahead and create our app. And since we're treating this as a separate front end and separate back end, we'll need to take into account the fact that we have to deal with CORS issues, so cross-origin request things. And HTMX has a nice little section in their docs where they explain what are the things that you should allow. For the sake of what we're doing, I'm just going to go ahead and just allow everything. And this is not something you want to do in production, but for the sake of what we're doing, it's going to be absolutely fine. Next, we're going to go ahead and load the data. And next, we'll create the route that we're going to be using to fetch the data. In this case, it's /data. It's going to be an async function, and all we're going to be taking in as an argument is search input. In this case, we're just saying it's going to be an optional string, and it's going to be initiated to none. The query object here is just going to let us parse the form data that comes back from HTMX in this case. We're going to copy over the data into a results container, and this is more for semantics than it is anything else. And we're going to initiate the HTML content that we're going to be sending over. We noticed we had a search box, so what we're going to do is we're going to check if there is search input, and then we're also going to create a filtered data set that we can use to grab all the filtered objects. So for a person in data, so for our object in our objects, we're going to check if search input is in the person's name. Right now we're only searching for name for the sake of the example, and then if the person is not already in our filtered data, to avoid duplicates or a few in the list, then we can go ahead and we can append the data to that data set. Then we just set that to results, and if there are results, then we're going to go ahead and iterate over that in order to generate the HTML that we're going to be sending over to HTMX. So in this case, we're going to do for item in results. We're going to go ahead and generate the content. And what we'll do is we'll create a div. This has some Tailwind classes, basically CSS variables in class form. And then we'll go ahead and we'll add the image and some classes for that. We'll add the container that's going to house the little notes, the information for each of the fields. So we'll have the name, we'll have the ID, species, origin, location, episodes. And then normally we just return that HTML content. But since we don't know if we're actually going to have any matches, we probably should account for the fact that there might not be any. So we'll go ahead, and if there are no results, then we'll generate some HTML content for that. In this case, it's just going to be a div. And this is where things get interesting because we're going to be using an HTMX swap out of bounds. And what this means is that we're going to be swapping out a container that isn't the container issuing the request. And we'll take a look at how this works in a second. The inside of the container is just going to be a Giphy and a note that says nothing was found. And in case if you were wondering, this is what that GIF looks like. So clearly it's a catastrophe if we don't find anything. And the last thing we need to do is just actually run the server. So to do this, we'll just use the Uvicorn run command, and we'll point it to backend. And we'll also add the port and set it to reload to true. I'm going to set the port to 8005. or 6 because I already have something else running on the side. And as far as the backend is concerned, that's basically it. Now let's go ahead and take a look at the front end. But before that, we should probably run the server. So I'll go ahead and do a Python backend.py, and we'll just leave this here. I'll just close it out. Now for our index.html file in VS Code, we're going to be using the live server app to actually host it. And once we go to that URL, we'll see that we have a blank page. And we can use Emmet to add the boilerplate for an HTML. We can change the name to Rick. And next we'll go ahead and we'll add our Tailwind installation. I'm using an older version just because the linting wasn't working for the new one. We'll also add the HTMX installation with the CDN. And in order to have the indicator disappear instead of just fade away, we have to add this styling. So we'll add the HTMX indicator class and the my indicator class in order to set it to display none or inline when it comes in and out. We can also go ahead and indent this because why not? For our body, we're going to go ahead and add some Tailwind classes to change the background and the flex box setup. We'll also add a navbar, mostly just so it feels like an actual page. These don't actually do anything. Next, we'll go ahead and add a title banner. This is actually from the Twitter profile for Rick and Morty. Okay, and next we'll add our search section, which right now doesn't really look like much, but we'll add an H1 and an input, and then we'll style those with CSS from Tailwind. And then we'll give the input an ID, which is going to be important later. We'll give it a name in order to access that parameter from the form. You'll notice that it's the same that we used in the backend function. We'll set it to type text and we'll give it a placeholder. Okay, now it's time for the meat and potatoes. So this is going to be the div that's going to contain not only all our elements, but also the actual HTMX request itself. And normally I like to open this up a little bit just to give us some space to work with. And we'll give it some classes in order to set up the container attributes. We'll give it an ID. We're going to set the HTMX API endpoint where it's actually going to get the data from. We're going to set up some triggers, and this is what's actually going to set up the HTMX request. So on load, it's going to issue a query, and we'll see that it automatically started getting stuff in. And then we're also going to go on key up when it's changed with a delay of 400 milliseconds from our search input. And the way that this is written is very important because we want to have the colon in there and then the ID of the attribute that's going to trigger that change. And then we're going to tell it what we want to swap. In this case, inner HTML. That's the default. Normally I like to have it in here just so that we know visually looking at it where the stuff is actually going. We'll tell it to include the search input, because if we don't, then even though the search box triggers the request, it won't actually send that text data along with the form. And then we can go ahead and we can tell it what the indicator is going to be. We haven't created this element yet, but we want to let it know, hey, hashtag indicator. The ID of indicator is going to be the thing that we're looking for. Okay, and next I'll just paste in that indicator. It has classes of HTMX indicator and my indicator, which are important. And then we notice that it's outside of the element. And this is why I added that ID over here, just so it makes it easier. You can put these kind of loading fidget spinner things anywhere you want, as long as you tell HTMX where the indicator for that request is, then you can very easily add animations to pretty much anything. So if you have different requests on the page, maybe one is a search, maybe another thing is like an account thing, you can have these animations anywhere. And then we can just add that placeholder div for the errors. And the hx swap parameter that we had set up on the HTML that we're setting back in case of an error, this tells it find the object with the same ID and swap it out. That means that any element on the page can be swapped out this way. So if there's other buttons or login icons or anything like that, they can all be swapped out in the same way. And the only other thing that we have to do in order to get this all working is add this hx_on parameter to the get request. The hx_on is essentially just an event listener. So if you're familiar with JavaScript, you know what that is. If you're familiar with Python, you might not. So what this is doing is just listening for when HTMX issues this specific event. Other events includes click or on page load, similar to what we have up here for triggers. And what it does is we can run a function against it. So in this case, all I'm doing is find the error element and then set the inner HTML to an empty string. And that's essentially going to clear it out to make sure that we still don't have that there when we issue the request. Okay, one thing I forgot to do was change the port for the backend we're using. So in this case, for me, it's localhost on 8006. If we want to simulate a load, we can go ahead and add a sleep. And now we see that the loading icon actually does pop up. I'm going to set this to 2 just so it's a little bit shorter. You may not have noticed, but the loading icon doesn't always pop up. And that is not because it's not happening. It's because there are still items in the container. So one thing I forgot to add was to also find this current container and also empty this one out. And then now when we search for mum, it'll replace it. And then if nothing comes back, the other one pops up. This hopefully gives you an idea of how you would set something up like this with HTMX. And you'll notice if you go to something like Disney Plus and we do a search for it's a very similar situation. And some of these animations we can actually add with HTMX. It's just beyond the scope of this video, but it's a very similar situation where the active search is part of the magic. If you have some images you want to host up, you can now do it with HTMX and whatever backend essentially you please. I did this FastAPI just because fast is in the name, so it's quick. You use whatever you want because all you're sending back is an HTML string. We've reached the end of this video. If you liked what you saw, please do thumbs up and subscribe and tip. We don't tip on YouTube, and bell and all that stuff. Anything you didn't like or anything you would like to see in the future, feel free to leave a comment and I'll be sure to keep a tab on those. So until next time, happy coding.